Okay, we're going to start with the top question here. So this is a water crystallization question. So it gives us a mass of the nickel sulfate with the water surrounding it, and it's heated to remove all the water crystallization. It tells you that solid remaining has this mass here. Now this is actually just a fancy empirical formula question, because what we can work out is the mass of this, which it tells us, that's the amount that is left, 1.344, and therefore the rest of this number here must be the water. So the mass of nickel sulfate in that sample is 1.344 grams, so therefore the mass of the water in that sample must be 2.287, take away 1.344. So that equals 0.943. So the first step of an empirical formula question is to divide the mass by the MR. So I'm going to divide the mass of the nickel sulfate by the MR of the nickel sulfate, which you can work out to be 154.8. That's something you need to work out first by adding together all the relative masses. So that's 154.8. And the MR of the water equals 18. So you're going to divide the water mass by 18. So see how this is very similar to an empirical formula question. We're not dividing by the atomic masses, we are dividing by the molecular masses to give us a ratio. So that then gives us a ratio of 8.68 times 10 to the minus 3 to 0.052. And if we divide both sides by the smallest number, 8.68 times 10 to the minus 3, divide this by 8.68 times 10 to the minus 3, so that should be minus 3 over there. That then gives us a ratio of 1 to 6. So x equals 6. Make sure that you don't just leave it as 1 to 6. It asks you to calculate the value of the integer x. So you've got to finish by writing x equals 6. And the second question down here says boron trichloride can be prepared by showing that equation. A sample of boron oxide was reacted completely with carbon and chlorine. The two gases produced occupied a total volume of 5,000 centimeters pressure. Calculate the mass of boron oxide that reacted. So whilst this is an ideal gas equation question, we are going to follow Mr. T to work out moles, ratio and triangle. It is a moles question in the end because we're working out the mass of the boron oxide that reacted. So it tells us that the gas that is made on this side occupied a total volume of 5,000 centimeters cubed and a pressure and a temperature. So we're going to use PV because an LT first to work out number of moles as in Mr. T. So we'll follow our method that we're always going to use. So the pressure we've got there is 100 kilopascals, so we'll convert that to pascals. The volume we've got as a centimeters cubed, so we've got to multiply that by 10 to the minus 6 to turn it into meters cubed. The moles is what we're trying to work out. The gas constant is 8.31 and the temperature is already in Kelvin. So to work out moles, that's going to be PV over RT, which equals 100,000 times by 5,000 times 10 to the minus 6 over 8.31 times 298. So that gives us a number of moles of 0.202. Now, that's the total moles of gas, not just the moles of one of those things. So you can see the total moles of gas is 5. So actually the ratio that we need to do next is going to be 5 to 1, because there's only one boron oxide for every 5 moles of gas on the side. So the moles of the boron oxide is going to equal 0.202 divided by 5, which gives us 0.0404, and then the T stands for triangle. We've got to use the appropriate triangle to work out mass. So the triangle that has mass in it is mass equals moles times MR. So the mass of the B2O3 is going to equal the moles, 0.0404, multiplied by the mass of the MR of boron oxide, sorry, which is 69.6, which you'd have to work out first. And that then gives us 2.81 grams. So this is another just moles question really. So we're going to follow Mr. T again, moles ratio triangle. So it says calculate the concentration of molybdenum cubed of hydrochloric acid produced when 43.2 grams of boron trichloride are added to water to form 500 centimetre cubed of solution. So the first thing we can do is work out the moles of something here, and that is the moles of boron trichloride. So the first thing we've got to work out is the MR of the boron trichloride, and that equals 117.3. So therefore the moles of boron trichloride is going to equal the mass over the MR, which is 43.2 divided by 117.3. So that gives us 0.368 moles of boron trichloride. Now we can do the ratio, and the ratio of the boron trichloride to the hydrochloric acid is 3:1. So therefore the moles of the hydrochloric acid will equal 0.368 multiplied by 3, which equals 1.105. Then we've got to do the appropriate triangle. So we're trying to work out the concentration. We've got to go back to our question and look at what we're trying to work out. So working out the concentration of the hydrochloric acid. So the appropriate triangle here would be M equals C times V, because we're trying to work out the concentration. So to work out the concentration of hydrochloric acid, we're going to have to do the moles divided by the volume, which equals 1.105, divided by the volume, which is 0.5 decimeters cubed. Notice this is in centimeters cubed, so that is equal to 0.5 decimeters cubed, and that gives us 2.21 moles per dm cubed. And the last question on this set of questions is the boron trichloride can be reduced by using hydrogen to form pure boron. Calculate the percentage atom economy for the formation of boron in this reaction. Apart from changing reaction conditions, suggests one way that a company producing pure boron can increase its profit. So the percentage atom economy. So atom economy, first you've got to know the equation. That equals the MR of the desired product divided by the MR of all products. So the MR of the desired product is the formation of boron. So the MR of boron is 10.8, and there's only one of them in this reaction that's made, so it's 10.8, and the MR of all is going to equal 10.8 added to 3 times HCl, and HCl is 35.5 plus 1, so 3 times 36.5. And if you do that and add it all together, that gives you 120.3. So the atom economy is going to be 10.8 divided by 120.3 times by 100. Sorry, I should have put that at the top here. It's a percentage, so you've got to do your fraction, then times by 100, and that gives you 8.98%. Now, the only answer to the next question, which is apart from change reaction conditions, just one way a company producing pure boron could increase its profits to reaction, is sell the other products. So we've got HCl here, so if they find a buyer for that, then obviously that's going to increase their profits, because then it wouldn't be a waste product, it would also be a desired product.